So today our group are going to present about the assignment 1 for our technical drawing and CAD. Our group is called Snoop Goat and we are composed by 5 students enrolled in BDA 10703 technical drawing and CAD at UTHM. And as part of the problem-based learning, we work together to complete a project involving the design and drafting of a Snoopy Lego. And then we select and measure 5 components for each person and then create initial sketches and dimension. Uh, Also use AutoCAD software to produce a detailed drawings. So here are the 5 person in our group, which is Lim Yi Hong, Zhe Kai Liang, Wu Kai Jun, Liang Xizhen, and me, Lim Hongzhe. So the goal for this project is to defend the project, demonstrate the ability to defend a drawing project in a formal report, while understanding Snoopy Lego features design, function, and its specification. Also, we are going to do the accurate drawings, create precise isometric and orthographic drawings for the 25 components chosen in the Snoopy features using AutoCAD to show proficiency, and also modeling technique. Practice advanced modeling technique to design intricate shapes and improve AutoCAD skills. The product chosen by our group is the Snoopy Lego, designed for all age groups, for children ages 6 and above. It makes from durable, non-toxic ABS plastic to ensure safety and quality. It promotes creativity, fine motor skills, and cognitive development through hands-on assembly. For adults and seniors, it serves as a relaxing and rewarding hobby to relieve daily stress. It also encourages family bonding and provide cognitive stimulation, which may benefit seniors' mental well-being. Lastly, it is a perfect gift for any occasion, fostering creativity, connections, and enjoyment for everyone.
So this is the product tree diagram. So basically, the 25 components are actually divided into three categories, which is the first one is base Lego, named as 0.1.01. The second part is decoration Lego, named as 01.02. And the third part is rocket Lego, named as 01.03. So for the first part, base Lego, there are six part for it, which is base one until base six. So the part number for this category is LG 01.01.01 until LG 01.01.06. So for second part, the decoration LG, there are seven part for this category, which are decoration one until decoration seven. So the part number for this category are LG 01.02.01 until LG 01.02.7. So when come to the rocket Lego this category, there are 12 part for this category, which are rocket 1 until rocket 12. So the part number for this category are LG 01.03.01 until LG 01.03.12. So the 25 component were distributed to every member. Each member have five components from the three category, which is the base, the decoration, and the rocket. So as you can see from the slide, this is the table that we name for every single component from the product. The table shows the name of the component, part number, main view, and the other side view diagram. This is the task distribution for this project. So every member have their own task to in charge of five components of the product.
So now for our Gantt chart. So the task has been distributed into 7 categories. And for the first task, we project instructions that are given by lecturer, and we have created a group of with 5 members, and this has been done on the week 6. And the second thing is we conduct a meeting, and a Snoopy Lego figure is chosen for our project, and this was done on the week 7 and week 8. And for the third task, we have distributed 25 parts, which divided into 5 parts for each member. And this was done on the week 9 and week 10. And for the fourth task, we have drawn the isometric and uh, orthographic projection of each component by using AutoCAD. And this was done throughout the week of week 10 to week 12. And for the fifth task, we have written a full report of the task that we have done. And this was done during week 12 to week 14. And for the sixth task, which is checking the presentation, we have done on the week 14, and we will submit the report on week 14 also. Now we move on to our measurement methods. So there are two main measurement methods that we have used, mainly digital vernier caliper and ruler. So for digital vernier caliper, we can measure the length, width, and depth of the figurine with precision. It features an LCD screen for digital readout and button for power, zero reset, unit conversion. And it can be accurate up to 0.02 mm, which is suitable for parts that are that reach a length up to 150 mm, and it requires calibration to zero before using. And for ruler, it is an essential and quick approximate measurement for drafting, and it can be used for initial stages and design of our sketching, and it can help replace some parts that can be measured using vernier caliper.
Now I would like to talk about my part, which is the initial sketching. The reason why we do this initial sketching is because we need to have a rough overview for our AutoCAD design and documented measurement of the product's component. So every before we do our actual AutoCAD project, we must sketch our own pieces on a draft paper or a A4 paper. We will be using the dimension in either cm or millimeters. So here's the initial sketching for our Lego piece. As you can see, we will label each Lego piece with their part numbers and also their names. We also can categorize every pieces, like for example, the dimension, the dimensions for each Lego pieces, the names for each Lego pieces. Like for example, if that piece is from the rocket parts, then we will label rocket. If the piece is from the base, then it's labeled to the base as a category. Here are also some sketching that are labeled and also with their dimensions. And as you see, they are labeled rocket and with their part numbers. So after doing the sketching, we will use the AutoCAD software to draw our components using AutoCAD software on the title block. So the reason why we use AutoCAD software because it's uh, distinct to single components and also exclude parts like burrs and access. We can also use AutoCAD software to draw the orthographic and also the isometric views of the uh, parts from our Lego pieces. We will label for our parts like top view, front view, side view, and also the isometric view using our AutoCAD software on the title block. And for our, by looking at this, we also labeled for each dimension and also its part numbers. Each group member will choose 5 parts to draw on the AutoCAD software, and each part must be labeled properly, and which also their dimension and part number. Here are also some AutoCAD drawings that our group members did. So the following are the AutoCAD drawings that our team did for this AutoCAD project.
These two are the following AutoCAD drawing with isometric and orthographic projection of our figurine part that we have chosen. Same thing goes for these two parts with decoration part number 5 and base part number 6. These two are the drawing for rocket part number 9 and rocket part number 10. These two drawing are decoration part number 6 and rocket part number 11. These following two drawings are decoration part number 7 and rocket part number 12.
These pictures are the drawing for project and they are under rocket compartment with the first picture is called rocket 6 and the second one is rocket 7. Moving on, these pictures are under base compartment where first picture is base 2 and the second one is base 3. Lastly, this is base 4 which indicates it is under base compartment. In this project, we have faced the problem of difficulty in measure curve and internal parts with vernier caliper, which causes inaccurate value. To overcome these problems, we may use flexible thread for the measurement, then mark the thread with a pen and then measure its length with a ruler. For drawing issues such as not being able to apply polar array to ellipse in isometric drawings, and the lack of fillet option for isocircle, switching to SolidWorks may be a better option for 3D for its functionality and versatility. To handle the resizing of components for orthographic drawings and the title block, categorize components by size and draw them in separate files. This solution should make the process of measurement and drawing easier.
In conclusion, we applied technical drawing and CAD skills to design and represent Snoopy Lego's components, including precise measurements, sketches, and AutoCAD rendering of orthographic and isometric views. We addressed challenges like measuring intricate parts, creating complex shapes in AutoCAD, and managing size difference by using flexible traits and recommending SolidWorks for certain tasks. Through this project, we strengthened our teamwork, technical drawing expertise, CAD proficiency, and problem-solving skills, equipping us for future engineering and design projects.
That's all for our presentation. Thank you so much.